Good morning, everyone. I am here to discuss about the electromagnetic spectrum. So, can you still remember the different forms of electromagnetic waves? While all these electromagnetic waves move through space at the same speed of about 300 million meters per second, their wavelengths, frequency, and energy differ. This is the reason why they are arranged accordingly in scheme called electromagnetic spectrum. Wavelength has an inverse relation with frequency and energy. So, if wavelength increases, what will happen to the frequency of the wave? If the wavelength of an electromagnetic wave decreases, what will be the effect in its energy? Let's compare the relative wavelengths, frequency, and energy of the different region of electromagnetic spectrum. At the end of this lesson, you will be able to first understand the different region of electromagnetic spectrum. Second, cite examples of practical application of the different regions of electromagnetic spectrum. And the last one is explain the effects of electromagnetic radiation on living things and the environment. So look at of these two figures, the figure 1 and the figure 1.1, the diagram of the electromagnetic spectrum. This chart shows that the longer the wavelengths, the lower the frequency, and the shorter the wavelength, the higher are the frequency. Observe that on the left end of the spectrum are waves that have longer wavelengths and lesser frequency than those on the right end of the spectrum. Radio waves, microwaves, and infrared belong to the low frequency wave. Low frequency waves are also the one that carry lesser amount of energy. On the other hand, ultraviolet, gamma ray belongs to the high frequency which carry greater amount of energy. Notice that there is a narrow band of waves in the spectrum. This narrow band is the visible light spectrum, which is the only electromagnetic wave visible to human. All the other electromagnetic waves are not visible. How do these waves affect us human, our environment, and other organisms? How do waves fit into the spectrum? First, the name of the waves, which one have high or low frequencies, the order they fit into the electromagnetic spectrum. Second, all of these are electromagnetic waves. This means that although they appear to be very different, in fact, they are all made of the same kind of vibration, but at different. Third, all electromagnetic waves travel at the same speed, about 300 meters per second, which is the speed of the light. So here are the 7 regions of electromagnetic spectrum. The electromagnetic spectrum is generally divided into the 7 regions in order of the decreasing wavelength and increasing energy and frequency. The common designations are radio wave, microwave, infrared, visible light, ultraviolet light, X-rays, and gamma rays. So, first, let's discuss the radio wave. Radio wave has been useful to mankind, making telecommunication possible. Among all the electromagnetic waves, radio waves have the longest wavelength and lowest frequency. As such, they also carry the lowest energy, which is not harmful to human and environment. Radio waves travel through the air. The waves are used by radio station to send the radios translate into sound. Radio waves have the longest wavelengths in the electromagnetic spectrum. According to NASA, ranging about 0.04 inches or 1 millimeter to more than 62 miles or 100 kilometers. They also have the lowest frequencies from about 3,000 cycles per second or 3 kilohertz up to about 300 billion hertz or 300 gigahertz. Second, let's go to microwaves. As time passes, scientists have proven that true radio waves are effective in communication. Microwaves, which have shorter wavelength than radio waves, can be more reliable, such as microwave technology is used not only in microwave oven but also in the mobile phone. In the late 1990s, communication companies started using microwaves in their mobile phones and began marketing the efficiency of the technology worldwide. However, humans may enjoy the technology, but the use of microwaves is not without adverse effect. When one makes a call using and microwaves one mobile phone, the mobile phone emits microwaves, resulting in warm sensation of ear and the phone. This is the reason why one should not use mobile phone in gasoline station. Moreover, when mobile phones are low in the battery, the microwave it can produce a greater than when it is fully charged. Microwaves have frequency ranging about from 1 billion cycle per second or gigahertz up to 300 gigahertz and wavelengths of about 30 centimeter or 12 inches to 1 millimeter or 0.04 inches. According to the Encyclopedia Britannica, this region is further divided into a number of bands with designations such as L, S, C, X, and K according to Ginger Butcher book's Tour of Electromagnetic Spectrum. And now let's move to the infrared. Infrared, which is between microwave and visible light, is produced by heat or thermal radiation or the radiation coming from the motion of the atoms. As such, everything that has heat has temperature about absolute zero gives off infrared. Even the human body radiates infrared when one subbats in the beach. One actually feels the infrared coming from the sun. Infrared is also used nowadays in medicine. In surgical operation, laser scalpel is used to cut living tissues. One type of the laser scalpel produces powerful infrared. As such, infrared may be present in the environment, but overexposure to it can damage the skin. According to NASA, infrared frequency range about 300 gigahertz up to 400 terahertz, and wavelength are estimated to range between 1000 micrometers and 760 nanometers or 2,921 inches, although these values are not definitive. And for the visible light, the visible lights falls in the range of the electromagnetic spectrum between infrared and the ultraviolet. And for the fifth region, the ultraviolet. The sun's rays also transport ultraviolet rays that can be harmful to the skin. Ultraviolet rays lie beyond violet in the visible light spectrum. Too much exposure to this energetic light may lead to skin cancer, dehydration, and other skin problems. To avoid skin problem brought about exposure to UV rays, scientists have come up with sunscreen lotion with UVA and UVB protection. Ultraviolet light falls in the range of the electromagnetic spectrum between visible light and X-ray. For our sixth region, the X-ray. X-ray is a popular electromagnetic wave being widely used to scan bones in the body and even luggage in the airport. It has truly been beneficial to mankind, especially in medicine. However, later discoveries have revealed that the use of X-rays to scan the human body is not without diverse effect. X-rays weaken the strong cells in the body. This is the reason why it is not advisable for a pregnant woman to be X-rayed because a cell of the fetus in her womb may not be able to withstand the energy. For the last region, the gamma ray. Gamma ray is which has a very short wavelength about the size of an atomic nucleus. Is often called the most penetrating radiation. It is the highest energy from a light in the universe. Sources of gamma rays include diffusion in the sun's core, supernovas, pulsars, quasars, black holes, and radioactive elements such as the radium and the potassium. As such, gamma rays are also present in the environment, and the overexposure to the electromagnetic wave can cause cancer to human and animals and excessive dryness to plants. Again, the seven regions of the electromagnetic spectrum. First is the radio wave, the microwave, the infrared, the visible light, the ultraviolet, the X-ray, and the gamma ray. After knowing the seventh region of the electromagnetic spectrum, let's go to the electromagnetic waves have a practical application which depend greatly on their wavelength, frequency, and the energy. So first, we have the radio wave. So the practical application is radio, television, and the signal. Radio and television signals are radio waves that are produced by making electrons vibrate. It has a low wavelength capable to transmit sound and picture information over long distance. And second is the global positioning system or the GPS. It's a space-based navigation system that provides geographical position and the time information anywhere on or near the Earth. It communicates with the station on the ground using the radio waves. The next is the magnetic resonance imaging or MRI. It is a medical imaging technique that uses powerful magnet, computer, and radio waves to make detailed picture inside your body. For the microwave's practical application, it has a satellite communication. Microwaves are used in satellite communication because it can penetrate the Earth's atmosphere. Microwave signals are transmitted by an antenna to a satellite which amplifies and retransmit the signal to an antenna in other parts of the world. This is how we communicate even from afar. The next is the terrestrial communication. A cell phone is a radio transmitter and receiver that uses microwaves. Cellular phones depend on overlapping network of cells. Each cell has its tower that receives and sends microwave signals. The next is the for cooking. The microwave in a microwave oven penetrate and agitate the water molecules within the food. Thus, they create molecular friction which produce heat that will cook the food. And for the last is the radar or radio detection and ranging. It's a detection system used to determine the range, angle, or velocity of object. It can be used to detect aircraft, ships, and the like. And for the practical application of infrared, we have the remote control or the infrared remote. Uses to the LED lights to transmit signal to control device. It emits pulses of invisible infrared light. And we have the thermal imaging through infrared scanner. Infrared scanners such as thermal imaging, and thermal scanner are used to show the temperature variation of the body. Our body radiates infrared under infrared cameras. Our image appear in variety of colors. The differences in color determine the differences in the temperature. For example, shades of blue and green indicates region of cooler temperature, and red and yellow indicates the warmer temperature. Then for the visible light practical application, it enables us to see the things around us. It also gives light to the screen of most electronic devices. Next is for the artificial light, like the flashlight, lamp, and etc., are any light source that produce light instead of the natural light produced by the sun. And last is the optical fibers. One use of the optical fiber in medicine is endoscope, a flexible tube with tiny cameras that is used to observe the internal parts of the body. And for the ultraviolet practical application, we have the ultraviolet B or the UVB radiation in the sunlight interact with a protein 7-DHC in the skin, converting into vitamin D3, the active form of vitamin D, which is essential for maintaining a healthy bone and teeth. And we have the security makings. Sensitive documents such as the credit card, banknotes, and passport, including a UV watermark that is only seen under the UV emitting light. And we have the sterilization of water in drinking fountains. Ultraviolet light disinfect is one water treatment system that can cause to remove most form of microbiological contamination from water. And for the last is we have the fluorescence. Some washing powder contains fluorescent chemical which glow in sunlight. This makes your shirt look whiter than white in daylight. Then we have the X-ray, the application, the practical application of X-ray. We have the diagnosing bone fractures. X-ray are produced using an X-ray tube. They are emitted when fast-moving electron hit a metal target. Long wavelengths X-ray can penetrate the flesh but not the bone. That's why it is used in diagnosing bone fracture. And we have the airport security scanner. The short wavelengths X-ray used can penetrate through metals which can use in airport security scanner. And for the gamma ray practical application, we have the treat tumors, and cancer through the process called the radiotherapy. The high energy rays of gamma ray destroy cancer cells in the area where it is given. Gamma rays sterilize surgical instruments because they easily penetrate through materials, and the energy they release kills bacteria and other microorganisms. After knowing the different practical application of the 7 region of electromagnetic spectrum, let's go to the effects of electromagnetic radiation on living things and the environment. From the practical application of electromagnetic waves discussed above, we can conclude that these waves are significant to us, but even essential form of radiation can be harmful in excessive amount. The effect of electromagnetic radiation on organism and environments depend on how much energy it carries. Radiation can be non-ionizing and ionizing. Non-ionizing radiation does not have enough energy to remove electrons from atoms and molecules. Radio waves, microwaves, infrared, visible light, and ultraviolet are non-ionizing radiation. We are exposed to low levels of non-ionizing radiation every day. When the exposure is intense and direct, it may result in damage to tissue due to heat. Right amount of non-ionizing radiation like UV rays maintain the proper mechanism of ecosystem. High energy electromagnetic waves like the X-ray and gamma rays are considered as ionizing radiation. Like the non-ionizing radiation, we are also exposed to low levels of ionizing radiation that comes from the atmosphere. This means that the usual amount of ionizing radiation from natural sources absorbed by our bodies is small. Our main exposure to ionizing radiation comes from the man-made sources through the use of diagnostic medical exams. Excessive exposure to this radiation can alter molecules within the cells and may cause eventual harm such as skin or tissue damage, cancer, and death. When handled improperly, radioactive pollution may occur, where the air, soil, and water will be contaminated. This pollution may eventually make its way up to the food chain where all the forms of life may be affected. So for the summary of this discussion, all electromagnetic radiation has the characteristic of particles or the photons and waves. The waves properties are most apparent at lower frequencies, while the rays of higher frequencies have the more obvious particles behavior. This class will focus on the visible and longer wavelengths. Notice that there is a one-to-one relationship between wavelengths, frequency, and energy of one photon. Higher frequencies correspond to a shorter wavelengths and higher energy photons. Electromagnetic waves are arranged according to increasing frequency in terms of hertz and decreasing wavelengths in terms of meter. Frequency refers to the equal number of waves that passes at a given point in a unit of time, while wavelengths refers to the distance between two successive parts of a wave. Electromagnetic waves possess energies in terms of electron. The energy of each electromagnetic wave is dependent on the frequency in terms of hertz. Wave's frequency is related to wave energy. The more energy in the wave, the higher its frequency, and the lower the frequency is, the less energy in the wave. When it comes to electromagnetic spectrum, gamma ray has the highest energy, while the radio wave has the lowest energy. For wavelength in nanometer, it is the other way around. As the wavelength increases, the energy decreases. So thus, the wave's frequency within the electromagnetic spectrum, the shortest wavelength in gamma ray and the longest wavelength is the radio wave. The electromagnetic spectrum is generally divided into 7 regions in order of decreasing their wavelengths and increasing energy and frequency. So the common designation are the radio wave, microwave, infrared, visible light, ultraviolet light, X-rays, and the gamma rays. So that's all for today. Thank you for listening, and God bless us all.